Uh, so first of all, I'd like to start off with the definition of a parabola. So a parabola is the set of all points equidistant from a given line and a given point. So you guys have some background with parabolas, but you don't have background with this definition. So like where did it start from? How is it defined geometrically? So there's this given point, which we call the focus. All right, and I'll put that here too. And a given line, which we call the directrix. Okay. And if we start with just that line and that point, and try to come up with all the points that are the same distance from both that point and the line, what forms is a parabola? So the easiest point to find is the point right in between them. And that point right in between them is what we call the vertex of our parabola. And so by this definition, we see that the vertex itself is the same distance to the focus as it is to the directrix. And then if we pick some point out here, and I looked at the distance to the line, which would be the perpendicular distance, and this distance to the focus, it'd have to be the same. They both have to be the same distance. And as you keep going out, it forms this parabolic shape. Okay, and so that's where the parabola comes from. It's a set of all these points, and no matter what point you pick, they are all the same distance to the focus as they are to the line, the directrix. So we're going to be talking about some of the stuff we've already done with graphing. You know, we know the vertex, we know the axis of symmetry, but then there's these other pieces. The focus has a lot of application to it in terms of, you know, if you're in a physics class, or if you're, you have a parabolic dish that sits on top of a house, like to receive things, and there's usually a microphone or some kind of thing that to receive your sound waves or light waves or whatever you're trying to get, because whenever those waves bounce off that parabolic dish, they're going to go straight to that focus and focus the signal there. And so it's got a nice application. The directrix does not have an application other than it's what's used in this definition. But I'm going to be giving you equations of parabolas and asking you, well, where is the focus? Where is the directrix? What's the equation of the directrix? And so we have a couple new pieces. So let's look at that. So what we have learned is this is the general form of a parabola. Y equals a times x minus h squared plus k. Right? And a couple examples of that might be y equals 2 times x minus h. Sorry, let me put a value in for h. So x minus 3 squared would be one example. Another example might be y equals negative 1/8 x squared plus 2. Okay. And in general, if this is our general form, what's our vertex going to be? You remember that? What is it? Vertex is a point, so you need an x value and a y value. be h comma k. What would the vertex of this next one be? 3, 0, because there's another thing out here. You could put a plus 0 if we wanted. And then this vertex. 0, there's nothing with the x, and then 2, right? Okay, so that's something we have done in the past. The axis of symmetry, or the line of symmetry, we have too. Let me start now with the little graph. So in this one, I'm just going to draw the parabola. We have our vertex here at HK. Here, we have a parabola opens up, right? How do we know it opens up? That's your positive 2. Good. Our vertex is at 3, 0. And here, this is going to open down with a vertex at 0, 2. And I'm not going to draw the x and y axis right now. What do we call the line that cuts right down the middle? Okay, line of symmetry, and it is a line, and so we want an equation of that line. So let's look at examples with the numbers first. So what would the equation of our axis or line of symmetry be in this one? You guys remember how? Yeah. What's that? Is it y equals or is it x equals? Right. If you have a vertical line, it's going to be x equals something. If you have a horizontal line, it's going to be y equals something. So this one is going to be I'll abbreviate AOS, axis of symmetry, is going to be x equals 3 here. Axis of symmetry here is going to be x equals what? 0. And the axis of symmetry in the general case is going to be x equals h. Good. And that's kind of about how far we've gone, right? So we have these other pieces. We have a focus that's inside. And the focus is always inside the parabola. And then I'll label that with an F, V for vertex. And then we have our directrix, which is is on the opposite side of the parabola. So if you think of the parabola as a cup, the focus will be inside the cup. The directrix will be like the table that the cup would sit on. So I'll put a D for directrix. And what do we know about the directrix and the focus in relation to the vertex? Equidistant. Okay. And I'm not going to take the time to do this, but we could prove what that distance is, and I'm just going to give it to you. That distance from the vertex to the directrix is going to be 1 over 4a, which is the same distance from the focus to the vertex, 1 over 4a. A is the number, in front of it's our leading coefficient. Okay? So 1 over 4a is that distance that makes it work, and we'd have to do quite a bit of proving to get there, and we're going to bypass that. So what would be the distance here? So if a is 2, right? Then 1 over 4a would be what? 1 over 8. Okay. And in the second one, if a is negative 1/8, what would 1 over 4a be? Okay. Negative 2. And if you're having, you could say, well, first of all, what's 4 times a? Right? 4 times a would be negative 4 over 8, which is negative 1/2. So this would be 1 over 1/2. And then if you have a 1 over a fraction, you can flip the fraction over. So I'll put out a few steps here. So this is 1 over 4 times negative 1/8, which is 1 over negative 1/2, which is negative 2. Okay. Now distance is not negative, but the negative is going to tell you the direction, right? So we're going down 2 to get to the focus in this case. So that distance is positive 2. Okay. Any questions? So what's the coordinate of my focus here? If this point is 3, 0, and I have to go up 1/8 to get to the focus from the vertex, what would the coordinate of my focus be? So I don't move left or right, so the x value stays the same, and I need to go above 0, so I'm going up 1/8 from 0, so 3 1/8 would be that, the focus. What would the equation of my directrix be? X equals or y equals? Y equals, and it's the height of your y value. So right here, the y value is 0, and I'm going down 1/8, so it would be y equals negative 1/8. Good. All right. How about in this second example here, what would the focus be? 0, 0. So don't move left or right. You went down 2 from 2, so that puts you at 0, 0. So that's going to be at the origin. And then what would the directrix be? So this is our focus. Directrix is going to be y equals 4. So in general, like let's go back to our general form. Can you give me an equation for our focus? Or like our vertex would be hk. What would the focus be? I'm at this point, hk, and I go up 1/4a. So do I add the 1/4a to the h or to the k? Okay. Does h change? Okay, so h stays the same, comma, k plus 1/4a. Now in this formula, if you apply this, if I do k plus 1/4a, it works in both these cases because here 1/4a is negative, so it drops you down. In this case, 1/4a is positive, so it moves you up. And for our directrix, that would be y equals, what would you write? K minus 1/4a. Good. All right. So those are the two new pieces, the focus and the directrix. Now, we can also reorient our parabola. Our parabola can open left and right as well. It would no longer be a function, but we're going to look at parabolas that open left and right. What do you think is going to have to change to make a parabola open left and right? Swap your x and y, okay? I get the inverse. So if we have, here's the general form. If I swap my x and y, it's going to look like this. X equals a times, I'm putting a y here. I'll use h, but we've got to be careful here. It's not the same h as above, plus k. So it kind of looks like our general form, but I just swapped the x and the y. And what this does is it makes it open left and right. Which way do you think would be the positive direction, to the right or to the left? Right. So this would open, if I by default, I'll put it in the positive direction. Not a function. So but we can have equations that are not functions. Our vertex is going to be where we thought it was. I'll put V for vertex. Where do you think the focus is? To the right of the vertex. Okay, so there's your focus. And the directrix goes this right here. Same definition. The vertex is still the same distance to the focus as it is to the directrix. But things have changed a little bit, and we need to be careful when we work with these. And so let's put a couple examples here as well. So let's say x equals 1/2 y plus 1, y plus 2 squared minus 7. And y equals negative 5 times y minus 1 squared plus 2. Okay. All right, so if a is positive, it's going to open to the right, like you said. If a is negative, it's going to open to the left. So this one's going to open to the right. This one's going to open to the left. And so what I do is I think, okay, if it starts with y, like up here, you're going to be thrown different equations. You got to say, well, if it starts with y equals, it's going to open along the y-axis. And the y-axis opens up or down. Okay. If it starts with x equals, then it's going to open along the x-axis. In this case, left or right. Positive direction is the right. Negative direction to the left. Once you know, okay, how to orient that, then you continue on. So what do we think the vertex is going to be for this function? Now you got to be careful. X and y have been swapped. Yeah. Not for this one? -7, -2. Good. So it's -7, -2. And how are we coming up with that? Well, the 2 is with the y. And we still use the opposite of that, which is a -2, but we're going to make that our y value because things are being swapped here. And then that what used to be our y value is going to become our x value. So things get turned around. And for the second example, what would our vertex be? 2, 1. Okay, so that I'll put V for vertex on these. So in general, what can we say about our vertex? If this is the form, our vertex would be K, comma, H. Good. Okay. How about our axis of symmetry or a line of symmetry? An equation, it's this line right here, cuts it right in half. Is it going to be x equals or y equals? This time, again, x and y are swapping places, and y equals, in this example, what's our y value? -2. Right? And axis of symmetry or line of symmetry here is going to be y equals 1. That's that line right there. And in general, our line of symmetry is y equals h. Y equals the y value. The distance from the vertex to the focus is still the same distance I told you, 1/4a. And the distance from the directrix to the vertex is also the same, 1/4a. And so we want to figure out what that is in these cases. So 1/4a in the first example here would be 1/4 times 1/2, which is no, it's the opposite of what you have here. So I have a negative h here, so I put a positive h here. So if I put a plus h here, then I would put a negative h there. So it's going to be the opposite. It's going to be the opposite. So whatever k is, you're going to use that. Whatever h is here, you're going to use the opposite. Yes. So here we get 1/. 4 times a half is 2, so you get 1 over 2. So that's the distance to my focus and to my directrix. And in this example here, we got 1 over 4 times A is 1 over negative 20. Because A is negative 5. And so that's the distance we're going to our focus and to our directrix. So in this first case, I want my focus, which is a point. What do we think it is? We're starting at our vertex, negative 7, negative 2, and I'm moving to the right 1/2. 1/2 is the distance from the vertex to the focus. What would I change? Would I change the negative 7 or would I change the negative 2? Good. If you're moving left or right, you change your x value. So I'll first write this. I'll write negative 7 plus 1/2, comma negative 2. And actually, I'm okay if you just leave it like that. Without simplifying it, I'm okay with that. And then the directrix would be x equals or y equals? X equals, because it's a vertical line. And what would it equal? Negative 7 minus 1/2, because we're starting at negative 7. Negative 7 is where the vertex is. I'm going back 1/2, so I need to subtract 1/2 for that x value. Here, my focus. Okay, so starting at the vertex, I'm moving to the left now to get to the focus. And I'm moving a distance of negative 1 over 20. So where's that going to be? 2 minus 1 over 20, comma, same height, 1. And then the directrix well, look at where it is though in my picture. If I'm starting here and I want to move to the left, I have to subtract. So I see where you're coming from. Let's put the general formula focus, and I think you'll see the connection. The general formula for the focus would be what? If the vertex is going to be k plus 1 over 4a. Comma h. Now, if 1 over, like what you guys are pointing out, if 1 over 4 is a is negative, it becomes k minus that number. But in general, it's 1 plus 4 over a. So here, if I do 1 plus 4 over a, 1 over 4a is negative, so it's going to be 2 minus 1. Which should make sense here because I want to move to the left, so you want to subtract. So make sure your picture makes sense with what you're doing here. Don't just rely on the formula. And then our directrix should be x equals what? 2 plus 1 over 20. Okay, good. So the homework I want to assign you is from worksheet 1, number 13 to 20. Okay? And on number 13 to 20, you're gonna find its vertex, its focus, line of symmetry, and directrix like we did here. And I want you to sketch its graph. The only thing that you're going to do that's different than what I did is I want you to put your x and y axis on here. Okay? Other than that, it's just going to be like what we did here. Okay? So number 13 to 20 is what I'm assigning you. And we'll stop there.